Does that make sense? Or yeah? No? Okay, so test the question, and I'm going to ask you each to take 30 seconds maybe to write out the answer, and then I'll write out it on the board and just test yourself. So what is the analog for 4? What is the analogous formula using a 4 instead of a 3? If I wanted to break them into 4 groups instead of 3 groups, what does this look like? Okay, everyone ready for the big reveal? Head was the butler? No. So I is 0 to n. J is 0 to I. Yeah. Okay. And now this looks horribly, horribly complicated. But if you think about it, not in terms of this. See? If you think about it not in terms of the symbols, but in terms of the story, it's actually pretty easy. So we've got n people. We choose I of them to not be in group 1. Of those I, we pick J to push into group 2. And of those J, we pick K to finally push into group 3. And that gives us 4 to the n. And now we can vary the size of the groups as we like. And this matches up to 4 to the n. Not happen? So 6, should I hand over? I can keep going, but either way.
I think should we just have a little time for questions?
Yeah, I'd love questions.
So how would you prove this?
How did we prove this?
How would you prove it? If they ask you to
You write out the story.
just like take that out.
Yeah, so you don't. So one way to do it is you can pull out the I and the J, and you can apply the binomial theorem twice. That works. The other thing you can do is say, look, there are 4 to the n ways to put 4 people into n groups. Now imagine if I wanted to put I people into group, well, n minus I people into group 1, n I minus j into group 2, j minus k into group 3, and n minus I plus jk into group 4. Well, there are this many ways to do that, and I can vary over I, j, and k, and that's it. Right? If you can write it out in a way that your peers would understand it, then that counts. That's what a proof is. Okay, and there's some wiggle room there.
Can I interfere again?
Yes, please.
If you work out this product, remember how we had a formula for this as n factorial over I factorial n minus I factorial. Then if you write out ij, write out each of these, multiply them together, something cancels, and you'll see that this is in fact just your binomial, trinomial coefficient, or multinomial coefficient. In the same way, remember we met the multinomial coefficients? After we'd been shown the binomials, we were shown the trinomials and then the multinomials. So this product is in fact the trinomial coefficient n. I don't remember exactly what it is, but it turns out into a trinomial coefficient. Do the sum. choosing j into one team, I minus j into another team, and n minus I into the third team. So the product of two binomials where these are the same is a trinomial. And then it goes on to quadrinomials and beyond.
Yeah, so you can always, you can kind of cancel these and shove them into trinomials or four numbers, and thanks for catching that.
So Doc, I did a Riemann sum with my guys this morning, and
Yeah.
it feels very similar. I'm sure they're thinking the same thing. Would you want to do the same here?
Well, so Riemann sum is sort of, you take as a limit to get to something. Here there's no limit. N's not getting smaller. So, not really in that sense.
Could you boundary it between a choice?
There are identities where if you divide things by sort of n to the n, that you do kind of break it down to a Riemann sum. For now, so I guess the point of Riemann sums is to do integrals, and there are integrals which quite closely match up with this. Really, if you're looking at n dimensions, that's a pretty good place where it pops up. And yeah, there is a link there, but I wouldn't throw that too hard at high school kids.
Just to tell you that in 2 weeks' time you're going to meet Professor Ridley, who lectured Jonathan and myself. And any of the other teachers here? Did you have Professor Ridley? So I'm really looking forward to that lecture in 2 weeks' time. And I think we need to thank Dr. Karev for this excellent lecture tonight, and I think we can give him a round of applause. A little bit of admin now, because I think you need to just stretch your legs a bit. Okay, I'm not sure where the register is. On whose desk is it? The learner's register. The teacher's register obviously also needs to be completed. But I think the easiest way for me to hand out the booklets now, and those of you who missed my announcement just now, the booklets is for you to take home to practice examples and maybe in your maths clubs at school or with your teacher and try some of those questions before round 3. The booklets you can keep till the end of the year, and then you can just return them to me, and hopefully the grade 10s and 11s who are here will be back here next year then for the training again. Our matrics won't be with us anymore, but they will hopefully be sitting in university seats and maybe come back to train Maths Olympiad. So I'm going to ask if you can come to that desk, that's where the Olympiad booklets are, and then just sign for the booklet. Okay.
Sorry guys, one other thing. So at the university level there is a tertiary Maths Olympiad for up to honours students, and we will be organising some seminars similar to this for our guys. And anyone here who would like to join, you're more than welcome. They'll be on Sundays from probably 12 to 3. There'll be a lot of clear problems, work on them, and we'll talk in between. And yeah, everyone's welcome, and maybe I should have brought like pen and paper to get a list of emails for interested parties, but
Do you want to give them your email address?
yeah, so let's use okay, now just for fun, who can tell me what's special about the number 496? There's another theoretic property to it which... Okay, so it's what we call a perfect number, which means that the sum of its factors, including 1 but excluding itself, add up to itself. So for example, 6 is, it's 1 plus 2 plus 3, and its factors are 1, 2, and 3. And 28 is, its factors are 1, 2, 4, 7, and 14, and that adds up to 28. And then the next one's 496, and the one after that is, I think, 8,128, and then 33 million and something, then 8 billion and something. So they're very rare. And another thing which just killed me that some friends didn't know. 1729. What's interesting about that? You know that. Yeah. Anyone else? So it's the smallest number that you can write as a sum of 2 cubes in 2 different ways. It's 1 cubed plus 12 cubed. So sometime last year I was talking to 2 friends who were in the comp sci department, and I was in stats, and I mentioned something about 1729, and they kind of looked at me funny, and then we went around asking people, and very few knew what it meant, knew this wonderful significance. And so I was very upset, but if you're going to see the man who knew